Okay, guys, this is the brave new world that we're talking about here. We are just getting set for the algebra online classes. So today we're going to go over section 7.6, which is more factoring. Uh, we're going to basically go over your student journal together, and we'll get started. So here we go with the student journal. Okay. As you can see, this is page, what page is this? Yeah, page 229. Yeah. So we're going to get started here with exploration 1. We're going to use algebra tiles to write each polynomial. I arrange the algebra tiles for the model for 2x squared plus 5x plus 2 into a rectangular array. Step 2, of course, you see that they did that. One thing I want you to notice is that the sides basically all kind of make this grid. I don't know if you noticed how they match up like that before, but they do match up. So this is a 2x, and this is a plus 1. This is a 1x, and this is a plus 2. So when we factor that at the bottom here, you'll get that x plus 2 and then 2x plus 1. So we're taking a look over here, and we're going to try and figure out what is this factored. Again, that side matches up with that side, this side matches up with that side, this side matches up over here with another x, so this is 3x, and this is plus 2 over here. So the first one will be 3x plus 2. Over here we've got an x, and then we've got a 1, so it's an x plus 1. And then the important thing to make sure that you actually did this correctly is to FOIL this out. So if we FOILed, we have 3x times x, that's a 3x squared. 3x times 1, that's a 3x. 2 times x, that is 2x. And then 2 times 1, that is a plus 2. And when I combine these terms in the middle, I'm left with 3x squared plus 5x plus 2, which is basically what I was supposed to have anyways. So it all kind of worked out. That's factored correctly. All right, so let's see over here. I imagine that they want us to make a 4x squared plus 4x minus 3, and they start us off with a 2x minus 1. 2x minus 1. So we're supposed to figure out what do we need to do here to get 4x squared. Well, let's see, that's only 2x squares. We need 4 of them. So here's the 4x squared. Okay. So that also gives me these tiles over here. So that's 4x squares. And then we're supposed to have a plus 4x. Well, this is a minus, so I don't know how that's going to work. You know, we've got a minus 1 here. We've also got a minus 1 here. So when we do these ones, you know, this is going to be a plus 1 because we have an x times a plus 1 is plus 1x, I'm sorry. Here's another plus 1x. These two form a 0 pair. So now I'm back to 4x squared plus 0. So I'm going to need more x's. So if we add another 1 there, we'll get 2. If we add another 1 here, we'll get 3. I'm sorry, we'll get 4. So now we've got plus 1 plus 2 plus 3 plus 4. So that's a plus 4x. And now over here we got a negative times a positive. That's a minus 1, minus 2, minus 3. All right, so that looks correct. We've got 4x squared plus 4x. Remember, these are positive negative pairs, so they cancel out. And then minus 4. So the other binomial in this factored trinomial is 2x plus 3. Okay, moving on. How can you use algebra tiles to factor ax squared plus bx plus c into the product of two binomials? Okay, so we're going to, lay out our tiles. Tiles with, I don't know, a x squares. So for example, 4x squares is equal to 4 big tiles. I think in our set those are blue. Okay, and then after we've done that, we're going to add the b x tiles. Okay, and we're going to fill in to make 0 pairs. If necessary. Then after that, we're going to just go ahead and fill with positive 1 tiles or negative 1 tiles as needed. Okay. But can we factor it without that trinomial? Yes, we can. Okay, so I said before that when we're in standard form, which is ax squared plus bx plus 1, if a is equal to 1, then we can do easy factoring. However, now we're in a place where a is not equal to 1, so we have to do the difficult factoring. So a lot of this works the same way that we did before with the x method. So the x method over here on top, we would put, I'm sorry, that should be a c. We should put a times c. Down here over here we put b. And then we figure out these two spots over here. Okay. Once we do that, we're going to go ahead and make kind of like an algebra tile thing, but we'll talk about that later in practice. So it is kind of like an algebra tile here, but without the tiles. So let's take a look at how that gets done. And then we factor. All right. How does this get done? Okay, we got more vocabulary here, of course, polynomial, an expression. Oh. Whoops. Dropped my pen. Okay, so of course a polynomial is an expression. Uh-oh. This happens when my batteries are kind of bad. Oh, I mixed it up more. Okay, so a polynomial is an expression with many monomials. Greatest common factor, I'm sure we can talk about, is the largest integer that divides into a pair of numbers. And a zero product property, this feels a lot like review again, but the zero product property says that if two things multiply to make 0, then at least one of those things has to be 0. Okay. Then at least one. I'm going to talk about how that's just good intuitive math sense. Okay, so we're taking a look at question 1 here. And we got 2c squared minus 14c and minus 36. So the first thing you need to do is, if you see that they have a greatest common factor, and they do, you want to divide that out first. So 2, 14, and 36, we can divide that all by 2. So 2c squared divided by 2 is just c squared. Minus 14 divided by 2 is minus 7c. And then minus 36 divided by 2 is negative 18. Okay, that looks pretty good. The first term here, c squared, well, no, what I should say is that 2 that I'm going to highlight right now, I'm not going to worry about that, and that's basically going to make its appearance at the very end of this, because now all I really need to factor is what's in the parenthesis. And I can do that with the easy factoring method. So let's do that with the easy factoring method. It's easy because the number in front of c squared is 1. There is no number in front of c squared, so of course it is 1. All right, so we're going to make our x method. Up at the top, we're going to do negative 18. Remember, this is just the easy method. And then a minus 7 on the denominator. Not the denominator, the bottom of the x. And we're going to start listing factors of 18 until we see one that can get us at 7. Okay, so 1 times 18. That's 18. Let's see. 1 plus 18 is 19. 18 minus 1 is 17. So this one doesn't work. How about 2 times 9? That's 18. Let's see. 2 plus 9 is 11, so it's not plus. 9 minus 2 is 7, though. So I think 9 minus 2 is going to work, or 2 and 9 are going to work anyways. However, I do get a minus 7 at the bottom. So instead of that, in order to get that 7, I'm going to have to do 2 minus 7. 2 minus 9, I'm sorry, is negative 7. So we got a 2 and a minus 9. This is easy factoring, so that's going to be c plus 2 and c minus 9. Remember the 2 that I said to hold on to? Yeah, we're going to put that on right now. And that is number 1 factored. Okay. Actually, that's not much different than what you were doing before. We were still using the easy x method. So let's do one more of those, and we'll try to find a more difficult x method. Let's see. Let's do number 6. Yeah, let's do 6. Okay. First thing I'm going to do is see, can I divide 3, 30, and 27 by anything? And yeah, I can divide them all by 3. So if I divide by 3, I get q squared. 30 divided by 3 is 10q. 27 divided by 3 is 9. Then I take a look and I say, hey, there's no number in front of q squared. So I can use the easy factoring method. So let's do some easy factoring. Big X method. 9 on top, 10 on bottom. Let's think of the numbers that multiply to make 9. That's 1 and 9 is the first one. And hey, 1 plus 9 is 10. So I don't have to go very far, and that's my answer. 1 and 9. Okay, so that's q plus 1, q plus 9, and we got that 3 in the front. That's it. Okay. All right, so I'm taking a look now, and I'm seeing question 6, and that looks like, I don't even know my numbers anymore. Question 8. That looks like one where we're going to have to use a more difficult factoring system. So let's do number 8 real quick. First of all, is there anything I can factor out? 6, negative 11, and positive 4. I think those are all relatively prime, which means that the greatest common factor is 1. I can't divide anything out of it. And, well, now I got to do the factoring. Okay, so it starts off like the x method. Slight difference. Instead of just putting a 4 up there, we're going to put 6 times 4. 6 times 4. How much is 6 times 4? Well, that's 24. And this is going to be the same. We're putting minus 11 on the bottom. Okay, so now we got to think of two numbers that multiply to make 24, not 4, 24. And so we'll start off by listing. We got 1 times 24. That's 24. 1 plus 24 is 25. 24 minus 1 is 23. So no, not 1. 2 times 12. Let's see. 2 plus 12 is 14. 12 minus 2 is 10. So it feels like I'm getting closer. 24. How about 3? 3 times 8 is 24. 3 plus 8 is 11. Hey, 3 plus 8 is 11. And we needed to get 11 also, but we needed to get negative 11. So I'm just going to make that negative 3 and negative 11. Sorry, negative 3 and negative 8. Okay. All right, so that was how we modify the x method. Notice it's mostly the same. We're going to go ahead and go to the next part of this. This is kind of a 3-part process. That's why students don't like this as much. 3-part process. All right, so here's our x. Over here, we're going to take what we started with, which was 6k squared. We're going to put it over here, 6k squared. And then we're going to put plus 4 in the bottom right. And then why did I bother with 3 and 8? Well, 3 and 8, these are going to go here. Negative 3, but this time 3k. Negative 8, negative 8k. And then we're going to factor each column and each row. So let's factor this out. Is there a number that goes into 6k squared? I'm sorry, is there a number that goes into 6k squared and negative 3k? Well, the greatest common factor of 6 and 3 is 3. Okay, it's going to be a number that's smaller than, or at least as small as the smallest. So 3, and then they both have a k, so I'm going to go with a 3k. Now you can make this a little faster by saying, hey, if I divide 6k squared divided by 3k, what do I get? Well, 6 divided by 3 is 2. K squared divided by k is k. So I got a 2k there. Okay. How about negative 8k and positive 4? Well, there's a negative sign here. So if there's a negative sign in the top box, I got to put that negative there also. So now it just becomes 8 and 4. What is the greatest common factor of 8 and 4? Well, that is 4. Okay, so now we're going to divide again. What is 4 divided by negative 4? Well, hold on. Yeah. 4 divided by negative 4, that is negative 1. Okay, so we can check to make sure that these things multiply, because this kind of works like a multiplication squared. So follow me if you can. We're saying 3k times 2k, is that 6k squared? Why, yes it is. Okay, how about, let's undo. How about 3k times negative 1? Do I get a negative 3k? Yeah, I do. So that works out. How about negative 4 times 2k? Does that give me negative 8k? Yeah, it does. And the last one to check is, how about negative 4 times negative 1? Does that give me positive 4? Yeah, it does. Okay, so I've basically created a multiplication table here, which means that there's actually a couple different ways of doing this same problem. All right, but let's get to the answer. We've got 3k minus 1 on the top row. And let me highlight that in yellow. 3k minus 1. And then you've got 2k minus 1 on the side. I'll highlight that also. Let's do that with blue. 2k minus 1 here, 2k minus 1 here. So that is the long factor. Difficult, right? A little more difficult. A little lengthier. I think I want to see that again. Let me tell you, no one gets good at factoring without a lot of practice. So let's take a look at number 9. We're going to start off by saying 9, 9, and 2. Can I divide anything out of 9, 9, and 2? I don't think so, right? Those are all relatively prime. So the number on top, 9 times 2, goes up here. Positive 9 comes down here. And now I start thinking. Let's think of numbers that multiply to make 18. 1 times 18. Okay, if I add those two, I get 19. If I subtract them, I get 17. So I don't think that's going to be the correct pair. 2 times 9 is 18. I can already see that this isn't going to work, but, 2 plus 9. Ooh, that was loud. 2 plus 9 is 11. 9 minus 2 is 7, so that's not going to work. How about 3 times 6 is 18? 3 plus 6 is 9. Oh, so I'm pretty much done. 3 plus 6 is 9. So plus 3 and plus 6. Okay, so now that I have that, let's get to my square. And I'm going to draw a less fancy square this time. Okay, remember, the first term goes in the top left-hand box, 9w squared. The last term, the constant term, goes in the last box, 2. And then these guys on the wings, they get put over here. Plus 3w plus 6w. Okay, looking at that first column, 9 and 3. What's the greatest common factor of 9 and 3? That's 3. They both also have a w. So we can do some dividing. 9 divided by 3 is 3w. 3 divided by 3 is 1, a positive 1. And then we have 6w divided by 3w. Well, 6 divided by 3 is 2. That went a lot faster now, didn't it? Once you start doing it that way. So my answer, we'll do the same thing. 3w plus 2. And down the side, 3w plus 1. Okay. That's our long factor. Okay, I'm going to do one more of these, and then we're pretty much ready to go. You can go ahead and start your work in the book. Let's see. How about we do, let's do number 12, the hardest one. I can't do air quotes. The hardest one. Okay. All right. Starting with my x. 5 times negative 9 is negative 45. Positive 12 goes down here, plus 12. And then we start thinking our factors of 45. Try to be systematic. 1 times 45. See, added, that's 46. Subtracted, that's 44. Doesn't work. 2 doesn't work. 45 is even. 3 times 15 equals 45. I think I have a winner here. 3 plus 15 is 18. 15 minus 3 is 12. Okay, so 15 minus 3 is 12. So I'm going to put a 15 and a minus 3. Time for the box. Okay, 5t squared goes here. Negative 9 goes here. And my guys over here on the side, they go anywhere. It doesn't matter what order you put them. 15t minus 3t. I could have switched them around. Those are the only two that you can switch around. The other two have to be right where they are. So let's divide. Is there a number that goes into 5t squared and 15t? 5 and 15 divided by 5 divided by 5 and 15. Yeah, I can divide them both by 5. They both also have a t. So 5t. All right. What's 5t and 5t squared? Well, I have to multiply that by a t to get 5t squared. 5t times 3 will get me a 15t. Okay, and then t times a negative 3 will give me a negative 3t. Okay, so we start, once we know that it's a multiplication square, then we can start multiplying things anywhere. Okay, so this is my answer right here. I've got 5t minus 3, and I've got t minus 3. Man, once you get good at this, it feels so good to finish these. And that's where we're going to end up today. That's the first one. Have a nice day, everyone, and get started on your big ideas. Ciao.